Yesterday, we just understand the reaction, that is a side reactions, or it is called as the parallel reactions, or also it is the name is competing reactions. Okay, so yesterday we understand what is the concept of side or parallel reactions. Okay, so those reactions which performing or decomposing the reactant to product, but in a more than one way, and it giving a different set of products. That reaction it is called as the side reactions or parallel reactions. But in which this reaction, those product it is maximum amount, that is main or major reactions, and the remaining reactions it is called as the side or parallel reactions. Okay, and the overall rate constant can be calculated. Such reactions, that rate of side reactions can be counted, account for this into the consideration of overall rate of reactions for this main reactions in the parallel or side reactions. We taken an examples of this one, that is if it is considered as a is converted into B and C. Let's see, this A is converted into B and C, right? So this is an examples of this one. General examples we consider it is, suppose this is a 90% product and this is the this 10% product. So of course it is a main or major product. Okay, and therefore it is a main reactions. This is very less amount of product, the it is called as the side or parallel reactions. But the rate of reactions, this one it is a K1 or this one is a K2. So the rate of reactions of your side reactions or the parallel reactions can be account for the to considering the overall reactions of this one, right? So this is the examples of side reactions or parallel reactions. So on the basis of this, we can find out the overall rate of reactions for this one. This is the overall rate of reactions for this one, and it can be, so we do the this rate law and the rate expressions for this one. That is the it is comes the ratio of to the to two rates given in the this rate law for this one and rate law for this one. So this ratio of this two, it is K1 upon K2, it's equals to, that is the rate of change of concentration of formations B upon with respect to time, and this with the ratio to this rate of change of concentrations of the formation of C with respect to time. So this one is the help to understand the overall rate of reactions for the individual rate constant of the formations B and formation C. And the once we know that this one, the rate for reactions B, formations B and C, will get the overall rate of reactions of the reactions, consecutive, side reactions or the parallel reactions. And we see the examples of this one. त्याचे examples आपण बघितले की suppose if you consider the examples of this one, this is your the nitrations process. Okay, so this is your toluene, right? The this toluene, if it is nitrates in presence of this HNO3, this is the concentrated uh, acid of nitric acids. It's this is the simple process of nitrations. We know that very well, the nitration process, which is the NO2 as an the electrophile, which is the additions or substitutions on the benzene ring, right? So this is a simple organic process which will be this reaction, it is gives the three products. Okay, so first product it is the your this one, that is CS3 and NO2. This is the ortho one. Then the second product which will form, that is the meta one. This one, this is CS3, and this is the product which will form, that is at the meta positions. You are nitrating nitrate NO2 group, which is substitute at the this positions. Okay, so this is the second product which will be formed, and third product, that is the para one. So this is your the toluene molecule, and it is attacks of your NO2 group at the position of this. right? Okay, so all the three products out of these three, so which one is the major product and which one is the side chain reactions or the side reactions? Okay, so out of these three, this is the three product from this one, this this one, this. So first, the second, and this one is the third product. Okay, so out of these three, first product, it is a main product. First product, it is a main product, and these two are minor product. These two are minor product. Okay, these two are minor product. These two are minor product. So these two minor product is called as, it is called as the side reactions or the parallel reaction. This is called as the side reactions or parallel reactions, right? So just keep in your mind why this product is main. So this is the remedy of organic chemistry, or that the mechanism it is behind of this, why this product it is major. Okay, so we know that this, if it is this exact structure of this one, याचं जर एक्झॅक्ट स्ट्रक्चर तुम्हाला माहित असेल तर ते अशा पद्धतीचं असते. दिस वन इज द एक्झॅक्ट structure of your molecules like this, and here is your nitrogen and it is like this. So this hydrogens and this one is the formations of the this simple hydrogen bonding. So just like this and hydrogen, it is a this six member ring will be formed due to this hydrogen bonding between this hydrogen and oxygens, right? So this hydrogen bonding gives the stability of this product, but this will not happen in these two cases. Okay, so if here this hydrogen bonding is not formed, this product it is always less stable than that of this one. Okay, so this is the exact remedy or exact chemistry behind it. Okay, and therefore this is the product, it is a main product, right? But sometimes ortho product it is less stable than that of the para or meta products. Why? Because here if it is bulkier group it is present here, so steric hindrance is there, and therefore it destables the benzene ring and it will becomes to the para positions and it will be more stable in another cases where the substitutions group are more bulkier, but here it not the case like this. Okay, so this is the less bulkier group and therefore it is formations of the hydrogen bonding, and this hydrogen bonding gives, this is the six member ring. After the formations of hydrogen bonding, six member ring give the stability to this benzene ring, and therefore this is the product, it is the very stable, and therefore it is the main reactions, and others two are the, this is the it is called as the side reactions. So this is an examples of your the side or the parallel reaction. So next reactions we just see the consecutive and the successive reactions. Consecutive and the successive reactions. What is the definitions of these consecutive reactions or the successive reactions? Yesterday we see in it, that is the what is meant by the consecutive reactions and the successive reactions. So the chemical reactions which proceed or which forms the to form a reactant to the product. Okay, through one or more intermediate stages. Through one or more intermediate stages. That reactions it is called as consecutive reactions or successive reactions. For example, if we consider the general reaction, that is A is converted into B and B is converted into C. Okay, so this is the reactions, it is called as consecutive reactions. So A पासून B तयार होते, B पासून C तयार होते. So once this is the final product, this one is your final product, right? And this is it product, it is called as an intermediate stage, and this product it is called as an intermediate product. Intermediate product. So such a reactions it is called as, such a reactions it is called as consecutive reactions or it is called as successive reactions. Okay, in these reactions this is a very simple and consecutive reactions, and in the both the cases, that is a K1, this is the rate constant for this formations of B from the A, and this is the rate constant for the formation of C from the intermediate product, that is B. Okay, so this two rate of rate constant, and it is indicated that this reaction it is the first order, and this reactions also it is the first order, because the rate of reactions or the order of reaction it is determined the where the which reactant molecule alter their concentrations or change their concentration during the course of the reactions which it is performing, right? So here is the single one and here is the single one, so both the reactions it is a first order reaction. Okay, so this velocity and velocity constant, the overall reactions of determine this lowest rate determining state. आता आपल्याला असं लक्षात येईल की याचीच इंडिव्हिज्युअल रेट ऑफ रिएक्शन्स किंवा हे आपण इझिली काढू शकतो जे आपण केमिकल कायनेटिक्स मध्ये फर्स्ट इयर सेकंड इयरला शिकलोय. ओके, पण इथे आता याचा एक इंडिव्हिज्युअल रेट ऑफ वेलॉसिटी कॉन्स्टंट आहे, याचा वेलॉसिटी कॉन्स्टंट आहे किंवा ऑर्डर ऑफ रिएक्शन्स आहे, पण ओव्हरऑल रेट ऑफ कॉन्स्टंट किंवा वेलॉसिटी कॉन्स्टंट किंवा ऑर्डर ऑफ रिएक्शन जर डिटरमाइन करायची असेल तर तुम्हाला it is a very complex process. Okay, so therefore we are considering the rate determining step. या दोन पैकी कुठली स्लो स्टेप आहे त्याला आपण आरडीएस म्हणतोय आणि त्याचीच फक्त रेट ऑफ रिएक्शन्स काढायची आहे किंवा वेलॉसिटी कॉन्स्टंट काढायचं आणि त्याला आपण काय म्हणायचं आहे, इट इज अ ओव्हरऑल रेट ऑफ रिएक्शन्स और द ऑर्डर ऑफ रिएक्शन्स फॉर द दिस कॉम्प्लेक्स प्रोसेस, राइट? नाउ एक्झाम्पल्स ऑफ कन्सिक्युटिव्ह रिएक्शन्स आपण त्याला काय बघितलेल्या ती दोन तीन एक्झाम्पल्स आपण बघितले. फॉर एक्झाम्पल द रिएक्शन बिटवीन द हायड्रोजन पेरॉक्साइड अँड हायड्रोजन आयोडाइड इन ॲक्वियस सोल्युशन्स ते आपण बघितलेलं आहे की इफ इट इज दिस इज द हायड्रोजन peroxides in presence of this H plus ions plus hydrogen iodide, this is the hydrogen iodides, and it is formations of the I2 as an gas. So this is the main reactions, but this reactions it is performing assuming that actually this reactions it is a second order reactions. We know that this is the second order reaction, this is the catalyst and this one is the one reactant and the second reactant. So the rate of reaction is depends on the both the concentration of this molecules, reactant molecule, therefore it is a second order reactions, right? But this assuming this is not a final reactions, this is the reactions which will be, it is the reactions which assuming the different processes are there. So for example, the first step is H2O2, that is the hydrogen peroxide reacts with only the your hydrogen iodide and it formations of H2O plus IO negative, and this is the process, it is very slow. Yesterday we just, then this product which will be again is reacts with this the presence of in a solution, that is your H plus ions, and which will be gives the product like this HIO plus this H2O. This is the very fast process, and again this HIO which will be produced in the second steps, second steps, which will be again reacts with the H plus ions, right? So this H plus ions and your hydrogen iodide, this is gives the product like this twice H2O plus I2. So this is again the fast process. So out of these three processes, this first process is it is very slow and therefore it is RDS. So overall reaction rate of reactions or the velocity constant can be calculated or determined from this reactions only. Okay, and therefore the order of reaction it is the here is the one reactant molecule, and both the reactant molecule can change their concentrations during the course of the reactions. So therefore it is the your rate of reactions or order of reaction only depends on this two reactant molecule, therefore the order of reaction it is 2, the order of reaction it is 2. So in this way we can find out the rate of reactions and the order of reactions of a consecutive or successive reactions. So if you know the second examples of this consecutive or the successive reaction, that is the decompositions of your acetone molecules in presence of this the thermal conditions. So this decompositions, for example, this is your the acetone molecule, this one is the acetone molecules, right? We know that this is the acetone molecule in presence of thermal conditions, which will be formations of ketene, formations of a ketene. Ketene it is just like this one is the ketene, and ketone is a very unstable molecules which will be not be stable. Okay, so this is the process, it is very slow, and this unstable molecules of your ketenes again decomposes into in the presence of thermal conditions, that is decomposes into this methane molecules. This is the ethane molecules, this ethene molecules plus carbon monoxide, and this is a very fast process. So out of these two processes, this one is the RDS. This one is the RDS, rate determining steps. And on the basis of this, we can calculate the rate of reactions or the velocity, overall rate of reactions or the velocity of reactions. So in this way, we see the different types of the different kinds of the reactions. Decomposition of sodium chlorides. So this is taking place again in two steps. So this is the hypochlorides, that is two this sodium hypochlorite. This is the hypochlorite ClO, and this is K1, that is the very slow steps, and this one is the formations of NaCl plus NaCl or 2. So again, this NaCl and NaClO2 will be reacts, that then NaClO plus NaClO2. If it is reacts with each other and it is formations of this NaCl and NaClO3, right? So this is very fast step. This is very fast step. So out of these two steps, this is the RDS. This is the RDS. So overall reactions or rate of reactions or order of reactions, we can easily find out the reaction. इथे काय असणार आहे, ओव्हरऑल रिएक्शन्स, रेट ऑफ रिएक्शन्स वी कॅन definitely find out this RDS. What is the order of reactions? So order of reaction, it is 2. So this reactant molecules, order of reactions म्हणजे काय, it is a simply sum of the concentration of exponent terms of this ज्या मॉलिक्युल्स वरती रिएक्टंट मॉलिक्युल्स ज्याचं कॉन्सन्ट्रेशन चेंज होते त्याचा एक्सपोनंट जो असेल किंवा त्याची जी असेल त्याची सम म्हणजेच काय असणार आहे तुमचं ऑर्डर ऑफ रिएक्शन. ही आपली डेफिनेशन आहे सिंपल. सो इथे दोन मॉलिक्युल्स आहेत, त्यामुळे याचा आपल्याला रेट लॉ लिहायचा असेल तर कसा लिहितो आपण, मायनस डीसी अपॉन डीटी. डीसी म्हणजे काय, तर तुमचं NaClO इज इक्वल्स टू दिस K into concentrations of NaClO raised to power 2. So it is 2 आहे, exponent 2 आहे याची टर्म. So order of reactions it is 2. Order of reaction it is 2. So this is all about the consecutive and the successive reactions. Okay. काल आपण याचे थोडेसे रेट इक्वेशन सुद्धा बघितलं होतं. ओके. सो दिस ऑल दी रेट इक्वेशन्स, आता त्याचे रेट इक्वेशन्स आपण जर बघितले तर आय जस्ट पुट हिअर रेट इक्वेशन्स, share this new sharing, right? So this is the rate equations for your this one, right? So this is the rate equations for your the consecutive or the chain reaction, consecutive reactions or the sequence successive reactions. This is an examples of this one, and we find out this one, right? So this the concentration of C. This is the final one, right? So once we know this one, we can easily find out the exact. So B is maximum the concentrations of the initial concentration of the reactant A, and this is the ratio of the K2 upon K1 raised to power K2 upon K1 minus K2. So this is the maximum or overall rate equations for your the consecutive. This is very complex process. Actually, the derivations will not be in your syllabus, but just to what is it, हे काय असू शकतंय, तर हे फक्त तुम्हाला याच्यासाठी आपण हे बघतोय. पण हे इक्वेशन्स किंवा हे डेरिव्हेशन्स तुमच्या सिलेबसला नाही, बिकॉज इट इज व्हेरी कॉम्प्लेक्स प्रोसेस. त्याला आपल्याला 2-3 पेजेस तरी आपल्याला डेरिव्हेशन्स करावे लागतील. हे इथं फक्त आपण काय करतोय, डायरेक्टली ते इक्वेशन्स ठेवतोय. ओके. सो exactly this is not the process to derive the rate equations for the consecutive or the successive reactions. This is only the steps which is the main steps. Okay. Now the next part of that is the chain reactions. The next इथे तुमचे consecutive किंवा successive reactions संपतात. Next part it is the chain reactions. or this chain reactions, it is very important reactions. And chain reactions, what is mean by the chain reactions? The chain reactions which proceed in a series, अशा रिएक्शन्स की ज्या सिरीज मध्ये तयार होतात किंवा सिरीज मध्ये perform होतात, that reactions it is called as a chain reactions. Exactly definitions of this reactions, it is the reactions or the chemical reaction which is proceed or perform in a series of successive stages and which is initiated by the suitable primary processes, that reactions called as, or it is known as the chain reactions. So which process? That primary processes involving the three steps. One is the initiation, that is the chain initiations, right? Second one, that is the chain propagations reactions. Third one, the chain termination reactions. Third one, that is the chain termination reaction. So these are the three steps which are stages or the reactions which will involve in the mechanism of the primary processes in a chain reactions. So one by one, just to understand what is the with the help of the examples of reactions between examples with the reactions between reactions between reaction between the hydrogen and chlorine gases, the hydrogen and chlorine gases. This is in presence of in presence of in presence of in presence of h nu. H nu is the sunlight. H nu is in presence of light or sunlight. So this is an examples of here, and we understand the chain reactions with the this suitable examples. And what is the mechanism of this primary processes? That is the chain reactions or chain initiations, chain propagations and reactions, and chain terminations reactions. Okay, so one by one, this is the chain initiation reactions, right? Chain initiation reaction. In this reactions, in the presence of light, the chlorine gas molecules is dissociated into the two radicals. For example, this is the Cl2 in presence of H nu or this light, it formations of Cl plus Cl. This is the two free radicals. This is the free radicals formations. Free radicals. And we know that the radicals, it is very unstable or reactive, right? So this reactions, it is a chain initiation reaction. This reactions, it is a chain because this radicals, once the radicals of chlorine atoms is formed, it is very reactive and it reacts with the H2 molecules. It reacts with the H2 molecules. So this hydrogen gas सोबत जर तो react होत असेल, the second reactions, that is the chain propagation. So chain propagation reaction, right? Chain propagation reactions. So the in a chain propagations reactions, this free radicals, which is formations in the chain initiation reaction, that is a Cl free radicals, this very reactive and it reacts with the hydrogen gas and it formations of HCl plus second radical free radicals, that is the hydrogen atoms free radicals. ओके, एक तर तो हायड्रोजन क्लोराईड तयार करतोय आणि दुसरा रॅडिकल्स तयार करतो. म्हणजे ही चेन प्रोपॅगेशन का आहे तर रिएक्शन इथे थांबत नाहीये. दूसरा तो रॅडिकल्स करतोय अगेन दिस फ्री रॅडिकल्स इट इज व्हेरी रिएक्टिव्ह. दिस रॅडिकल्स ऑल्सो इट इज व्हेरी रिएक्टिव्ह, राईट? So due to this reactivity of this radicals, again it reacts with the second molecule of Cl2. This hydrogen radicals, it reacts with the second molecule of Cl2, and this Cl2, it is formations of HCl plus Cl dot, again this radicals, this is the free radicals. म्हणजेच काय होईल की चेन रिएक्शन्स मध्ये एकदा का तुमचा Cl तयार झालाय रॅडिकल्स, तो हायड्रोजन गॅसची रिएक्ट होतोय, HCl तयार होतोय नो डाऊट, बट रॅडिकल फॉर्मेशन्स होतं, हायड्रोजन ऍटम्स रॅडिकल फॉर्म होते हायड्रोजन रॅडिकल फॉर्म होतोय तो परत Cl2 ची मॉलिक्युल्सशी रिॲक्ट होतोय, सेकंड मॉलिक्युल्स परत HCl तयार होते, पण Cl रॅडिकल तयार होते. ही रिॲक्शन्स ही जी प्रोपॅगेशन रिॲक्शन्स आहे ही थांबत नाही. परत हा रॅडिकल्स दुसऱ्या H2 काय होतोय रिॲक्ट होतोय, परत HCl तयार होईल, परत तुमचा हायड्रोजन ऍटम्स रॅडिकल्स हा फॉर्म होईल, परत हा H रॅडिकल्स परत Cl2 शी रिॲक्ट होईल, परत तुमचा HCl तयार होईल, परत Cl डॉट रॅडिकल्स. म्हणजेच हे जे रॅडिकल्स आहे ही प्रोसेस थांबतच नाहीये. Thus the reaction it is called as chain propagation reaction. म्हणून ह्या रिएक्शन्सला आपण काय म्हणतोय, चेन ही वाढतच जाते, म्हणून या रिएक्शन्सला चेन प्रोपॅगेशन रिएक्शन्स आपण म्हणतो. But the next and the third very important reaction, that is the chain termination reaction. आता ही रिएक्शन्स कुठेतरी थांबायला पाहिजे, म्हणजेच काय व्हायला पाहिजे, ही चेन प्रोपॅगेशन कुठेतरी थांबायला पाहिजे. So therefore the third mechanism or third process is involved in the reactions, chain reaction, that is chain termination. Chain termination reaction. So this chain termination reaction. So in these reactions, some possibilities are there. If जर तुमचा हायड्रोजन रॅडिकल्स हा हायड्रोजन रॅडिकल्सशी रिॲक्ट झाला तर H2 तयार होईल, म्हणजे रॅडिकल फॉर्मेशन होणार नाही, म्हणजे रिॲक्शन ही चेन रिॲक्शन थांबू शकते. सेकंड पॉसिबिलिटी आहे, दिस इज द फर्स्ट. सेकंड पॉसिबिलिटी आहे Cl रॅडिकल्स प्लस Cl रॅडिकल्स जर एकमेकांशी रिॲक्ट झाला तर Cl2 गॅस तयार होईल, म्हणजे रॅडिकल्स तयार होणार नाही, म्हणजे ही रिॲक्शन कुठेतरी थांबू शकते. थर्ड पॉसिबिलिटी आहे, इफ your H radicals plus Cl radicals which will already form in the reaction process, if they combines to each other, then again formations of HCl. So here is the no formations of any kind of the free radicals. There is the possibility to chain is terminated or chain will be stopped. And the fourth possibility is, that is hydrogen radicals, if it is the combine with the air, that is O2, HC जर तो react होत असेल तर it will formations of these two radicals. Okay, so this will formations of the H2O. This is formations of the H2O. So if it is formations of this is again the possibility of two formations of the termination of the chain reactions. So these are the four possibility to terminate the chain reactions, to terminate the chain reaction, and therefore it is called as the chain terminating steps. या सगळ्या स्टेप्स का आहे, पॉसिबिलिटी आहे चेन टर्मिनेटिंग स्टेप्स आपण याला म्हणतोय का, कारण इट्स ब्रेक्स और इट टर्मिनेट द चेन. ती जी चेन आहे ती चेन ब्रेक करते किंवा टर्मिनेट करते, therefore it is called as the chain terminating or chain breaking steps. So this is an examples of the chain reactions. This is an examples of the chain reactions. So this is the first example. Second examples of the chain reaction, it is the thermal decompositions of acetaldehyde. Just the thermal decompositions. See, thermal decompositions of the acetaldehyde. In the thermal decomposition of acetaldehyde, the free radicals, methyl radicals will be formed. The reactions between this, just see, सगळ्यांनी जॉईन व्हा, कारण इथे हे थांबते, आणखी वेळ आहे आपल्याला, हे एक्झाम्पल संपून जातील. ओके, so in presence of this second examples of this chain reactions, that is the second examples, that is the thermal decompositions of thermal decomposition of thermal decomposition of acetaldehyde, acetaldehyde, right? So this is the acetaldehyde CHO in presence of the temperature, that is 773 Kelvin, right? So formations of the methane plus carbon monoxide. So this here the free radicals will be formed. This is the main reactions, and this chain reactions, that is the CS3CHO in presence of the temperatures, that is the, it is formations of this, due to this temperature it is breaking the bond here, this bond will be break, and formations of these radicals plus CHO plus CHO radicals. ही reactions काय आहे? Radical formations आहे म्हणजे chain initiation, right? Then second step, this radicals, methyl radicals will be formed and it is reacts with the second aldehyde molecules. So CH3 radicals plus it reacts with the CH3O. It reacts with the CH3O. एकच मिनिट राहिलाय, नंतर सगळ्यांनी जॉईन व्हा. So this is the K1, this is the K2. Rate of reactions is or the rate constant or velocity constant. So it is the abstract the hydrogens from this acetaldehyde पासून abstract करतो and formation of CH4 plus the radicals of CH3CO. So CH3CO, this is the radicals will be formed. Again, this radicals, it is the reacts with this radicals